Thank you, and guten Tag, Heidelberg. They told me to stay here, so trying to stay here. So who was here last year? Yeah, so it's a little bit better air now because it's not 30 degrees anymore and you don't need to keep the door open so that we could have some kind of air. And who was staying at the hotel, Stay City Hotel? So good morning again. So we had a fire alarm at 2 a.m. So we had to go out and then try to go back to sleep. So I might be not in my best condition now, but let's see how it goes. Okay, so my name is Dr. Nestori Syynimaa. I come from Finland, and I work as a senior principal security researcher for a company called Secureworks. And you can find me from Twitter or Mastodon, whatever is your favorite social media platform with the tag Dr. Azure AD. I'm Microsoft's most valuable professional in security category, and I also saw some other fellow MVPs there, so hey, hi everybody. And then I'm also one of the most valuable security researchers, and also saw a couple of those here today. So every year in Black Hat US, Microsoft is publishing a list of 100 most valuable researchers, and I'm on that list second time in a row. I don't know, do I make it this year, but we'll see. And most of you know me from my toolkit called AADDS internals, and I'm going to use this today to show some demos, but I also have those stickers here, so if you want to get some after the talk, or do we have time for that? I don't know, but you can just, ask me when I'm wandering around here in the conference area. Now, last year when I was here, the corona has kind of gone away, not totally, so we had to wear masks, but anyway, the world started to open again. And it was my third talk last year, like in-person talk, and after that I had some others. So I started in RSAC, and then there was one event in Estonia, but Troopers was the third one. So this is what I've done during the last year. So I actually visited in 3 continents. I had 19 in-person events and over 25 talks or something like that. So yeah, it's been crazy. And this year I tried to do less, but I haven't been that successful so far because I'm here again. So anything can happen when you travel around the world. So here's one example. So this is from a conference called Identity Summit. It was here in Germany too. Well, not here, but quite close. And somebody took a picture and tweeted my picture when I was pointing some setting. And then Olaf Hartung, who is also MVP, said that that's a nice tip and it would also make a good meme. And then Ben Owens said that, hey, let me do that. So he made this. So now I have my own pointing stuff to do, and let's see if I'm pointing something today. Okay, so here's the talk of the content. So the name was dumping NTHashes from Azure AD, which sounds like a weird, but you can actually do that. And this is, I'm telling you a story, how I find this stuff, how it technically works, and how you could use this as a new attack vector to move from cloud admin to on-prem admin. And let's start by talking about Azure Active Directory and how it stores passwords. So this is what Microsoft says, that, for instance, that many people believe that Microsoft could access those passwords or password hashes, and they said that at least plain text version you can't access because it's never exposed to Microsoft. And it is using the same hashing algorithm or process that password hash synchronization is using. I think some of you know what that means, but maybe not all, but well, I can tell it to you. So also this new thing I found that Azure AD is storing password hashes for last 4 password hashes. I don't know why, but it stores them. And here's what happens when you are setting a password to Azure AD or when you are synchronizing that. So you will calculate the MD4, also known as NTHash from your password, and then you add salt and then run it through this BPKDF function number 2. and using HMAC SHA-256 as a hashing algorithm, and you do that 1,000 times. And then that is sent to Azure AD. Or if you are like changing a password, it's stored using this same procedure. However, if you are using a thing called Azure AD domain services, it requires to have NTHashes and some old Kerberos stuff. So it is possible that you can configure Azure AD Connect so that it is actually sending those stuff to Azure AD. So they are there. We know that. But how we can access that, that's the trick question. And by the way, this is what it looks like when Azure AD Connect is sending those passwords to cloud. So here's an example of password called password. Here's the MD hash or NTHash, MD4 hash. And when we are using different salt, the hash is always different. Also, you can see that here's this 1,000 iterations, which Azure AD is usually using. But using my AAD internal toolkit, you can actually select the iterations whatever you want to. So you can change like 1 or 2, it doesn't matter. I even tried 10,000, but it slows down a bit, so I was not able to log in anymore every time. So you can do that kind of things. Okay, so we know that they are password hashes. This is the common way to store that, and for sure Microsoft can't access that, so it doesn't know what is your password. It doesn't know what was the original MD4 hash. But as we saw, there are also like some legacy stuff stored there if you are using this, Azure Active Directory Domain Services, or AADDS. It is a terrible word combination. So, technical background, what is this? So here's the official explanation, but we can just keep that. It's also called by technical name DC as a service, or DCAS. And why I know that? Well, you're going to find out quite soon. But basically, what is the purpose of this whole AADDS? So if you are like cloud-only organization, so you have your Azure AD, but you have nothing in on-prem, but you would like to run something like old legacy system that requires domain services. Like if you have like a legacy financial system that is depending on the on-prem domain controllers or Active Directory, then you can deploy this to cloud and you can use that. But you don't need to deploy your own DCs because these are all managed. So everything is done for you. So this is the use case why this service exists in the first place. But there's one limitation, and it says that there's only one deployment per tenant. So if you have Azure AD, you can only have one AADDS deployed at any given time. And then what happens when you deploy that? So the topology is like this. So when you deploy that, you need to choose that what subnet you are using, and it automatically deploys 2 DCs there. And they have certain IP addresses, you need to figure them out, but you can see that from the Azure AD portal actually. And if you want to, you can also add other DCs. They are called replica sets, which you can add to other subnets. So if you have different subnets for certain, for any reason, you can add those extra domain controllers there. And these subnets doesn't need to be connected in any way because they are not replicating using that. I mean, the DCs are not replicating that, but they are using some Microsoft backbone network to do that. I don't know what, but they are just working. So I assume that it's Microsoft something like a backbone network. Because when you delete that AADDS, there are 2 NICs remaining that you can delete actually, because they are belonging to Microsoft subscription. And you just need to wait that Microsoft will delete them afterwards. But yeah. So this is the topology. And how you administer this stuff then? So, I mean the domain. It is there, it's deployed, it's managed, but you still need to do some administration. You can do that actually. So you can use the normal remote tools of PowerShell, but you need to have a domain joint computer to do that. And but you can join computers to domain, so it's just very easy. So you just deploy the domain in the same subnet, and then you just join that to that domain. So how can you add administrators then? So when you deploy this, there will be a new group called AADDS administrators in your Azure AD, and whenever you add users there, they are synchronized to the same group in that domain controller, or AADDS. And those people who you put in that group, they will have admin permissions. But they are not domain admin, so they can't do that kind of things, but they can add like TPOs, they can add users and groups and that kind of stuff, but that's pretty much it. So there's no domain admin permissions. Again, because this is managed domain controllers, managed by Microsoft. However, there's one built-in admin account which is actually domain admin. It's right there. And that's the one who we would like to be. Or it would be nice to have that user's password. Okay, so this is how you admin stuff. So now let's see how you deploy users to AADDS. So when you add users to Azure AD, it is automatically synchronized using some weird method to AADDS. And also if you have like hybrid organization, which means that you have connected your on-prem to Azure AD, and you add user there, it is also synchronized to AADDS if that's in the scope you have defined. So yeah, it's a kind of weird stuff, but this is how it goes. And you can also add users directly to that domain controller, which means that that is not synchronized from Azure AD or your on-prem. And we know that this synchronization between your on-prem and Azure AD, you can use Azure AD Connect or AAD Cloud Sync. However, you can't use it with AADDS because it doesn't support those legacy credentials that it is needed in AADDS. But how this synchronization takes place, that was the question when I started to research that how does this work? So I wanted to know how this works. And here's same in text. So basically the user in AADDS is a copy of Azure AD user, and if you have the hybrid, the Azure AD user is a copy of your on-prem user. So in other words, that user in AADDS domain controllers or Active Directory is not a replica of your on-prem user, which means that it has a different SID. It's just a copy, same name, same password, but different SID, and possibly even different net BIOS domain name. Because you can configure that when you deploy that AADDS, and it can be like something that is not related at all to your on-prem environment. And the synchronization with AAD Connect and from Azure AD to AADDS, we don't know yet. And at this point, I was done everything I could to do to study that. I mean, I read the documentation. I followed the process, so when I add user, what happens? And I noticed that the SID is changing and that kind of things. But I was like end of my way to study that. So I actually wanted to have domain admin to those DCs, those managed DCs, because otherwise I couldn't move forward in my research. And that starts our second part of the presentation, so attacking AADDS. And I'm honored to be able to work in a company like Secureworks because we have a lot of guys who knows a lot of stuff on like Windows, for instance. I'm not a Windows expert. I don't know how to get domain admin. So I had to bring in the big guns. So these are the two of my colleagues. They are both based in the US. Nevada Ronstal and Tony Gore. And actually it was Black Hat Europe. I think it was 12th of December or something like that last year. Nevada was also there presenting his tools. So I said him that, hey, I have a challenge for you. And he said, yeah, sounds good. Just send me the details. And then he and Tony, they spent like a week or so to try to attack the AADDS, and let's see how that went. So this is the topology we had. So we had a subnet with 2 managed DCs, and then 1 computer with admin tools. So we could see what's happening in DC, and in Active Directory. And then I also installed Kali Linux for them, because that's obviously what they used. I heard that people are using that, and that was first time I saw that in real life. So here's what they did. They used 2 techniques to get domain admin. I'm not showing what they are because they are having their own talk about this. But basically, there were 2 CVEs they used, and they were able to get domain admin. So they just called me, hey, Nestori, so what's your username so we can add you as a domain admin? And I said, okay, sounds good. And when you did that, you were able to dump NTHashes from those DCs. So that was that attack part. So you deploy AADDS, you get domain admin, and then you are able to dump NTHashes from AD. Because, well, you are domain admin and you can do pretty much everything. But that was not the end of the research. This is start of my research. So these are the on-prem guys, they were able to do this, but this is from where my kind of research only started. So now we move to researching AADDS. So what it actually is, what it does, and how it works. And let's see. So this is my research topology. So I have on-premises domain. I had Azure AD Connect running there. I configured that to use Fiddler because I'm the Windows guy, not the Burp guy. So that's why I did that. And also, well, I assume that AADDS, the domain controllers are talking to Azure AD or something else, so I also installed Fiddler there. So I was able to see what is happening between AADDS DCs and rest of the world. But that was just an assumption. I didn't know what it did. So this is what I did. Okay, so findings. So what happens when you deploy AADDS? So Azure AD Connect, it's always trying to get this get Windows credentials synchronization config from Azure AD before it starts synchronizing passwords. And I noticed that these used to be false, like enable Windows legacy credentials and enable Windows supplemental credentials, but now they are true. So that's the change. Also, there's some weird stuff called secret encryption certificate. So Azure AD is actually asking, Azure AD Connect is asking Azure AD that, do you want me to send you these legacy credentials? And if so, which certificate should I use to encrypt those? And then what happens when Azure AD Connect is sending that stuff? So it is actually adding 2 new attributes, so Windows legacy credentials and supplemental credentials, and then some weird blob here. So we can see the normal credential, like this is what Azure AD Connect is normally using when it's synchronizing password hashes, but these were extra stuff that was sent there. So I thought that those are important ones, and the first one is actually the NTHash blob. The other one might have a lot of different Kerberos kind of credentials which I don't understand, so you need to ask someone else. But but I knew that was the NTHash blob. So what is inside that blob? So that was quite interesting. And I don't know if you guys know a tool called dnspy, but it's a very nice tool to decompile .NET binaries, and I did that. And it turned out that Azure AD Connect is using a function called getADAuthInfo to encrypt those blobs, and it was located in that file. So if you want to go and see, it's in your Azure AD Connect server actually. So I open up that in dnspy, and it looks like this. So here we had 2 interesting things. So we have a function called encrypt, which encrypts that password or password blob. Didn't know yet what is inside that. And then we have another one, write ADAuthInfo, which actually creates that blob, which is then sent to Azure AD with that Azure AD Connect. And the encrypt one, that was easy because it's a .NET binary. So here we found encryption details, so which crypto provider we are using, which the cipher mode and padding mode and everything like that. And also I noticed that for some reason, when they first encrypt the encryption key, and after that they are reversing that. Why? Because that's Microsoft and they just want to make us life uneasy. But it was nice. I noticed that after trying a lot of things, but then, they are reversing that. Damn, it was not. Okay, but the second one, that write AD auth info, that wasn't like a .NET binary, so I had to use Kidra to decompile that. And here I found that what is the structure of that blob. But again, it's not easy because that's the first one, and then the second one is there, and third one, fourth, and fifth, and yeah. But anyway, this reveals that what is the structure of that blob that is sent, and it's here. So I'm not going to walk you through this, so you can see that by yourself after you get the slides. But basically, we have a header with some size information, then we have the thumbprint of the certificate, and then the encrypted encryption key. We have the initial vector, and the rest of it is the encrypted data, actually. That NTHashes blob. Now, what is inside that? So, those of you who have studied Active Directory know that there are attributes, and here's an attribute called Unicode PWD, which is actually that NTHashes. And it's just that attribute, nothing else. So we have the ID of Unicode password, then we have the size of the NTHashes, then we have the NTHashes, or MD4 hash, so it's the same thing. So that's what is actually synchronized to Azure AD. Then from Azure AD to AADDS, so what happens there? So now we know that Azure AD Connect is getting that NTHashes attribute. It is using the certificate it gets from Azure AD, and then it puts them all together and then sends back to Azure AD. But what happens then? So the documentation says that Azure AD is pushing that stuff using internal synchronization mechanism to that AADDS. So is it doing that? Well, we are about to find out. And then it says that those keys to decrypt that stuff is stored in Azure Key Vault, and only Azure ADDS is able to access those decryption keys, and nothing else. So, yeah. But how this actually works? So this is what Microsoft says it's doing, but let's see how it works. So it turned out that AADDS is using a service called DCAS AAD Sync Agent, and that agent is synchronizing those objects from Azure AD. So there's no pushing anything, but this is connecting to Azure AD and then getting stuff out of there. So yeah, it's using MS Graph API. So that's the secret synchronization protocol. It's just pure MS Graph API call, so nothing else. And the initial request is like here for users, so it's just using 1.0 users, and then it's selecting certain attributes. And then I noticed that there's something new here. So Windows legacy credentials and Windows supplement credentials. So those two attributes again. So they are there. And after the first one, it's using deltas. So Microsoft Graph Delta and then the Delta token which it got from the first request. So after that, it only gets the whatever is changed after the previous request. And that Graph API call is made in every 30 seconds, so it's quite fast. So if you had something to Azure AD, it should be quite fast in AADDS too. Okay, so me and my other colleague, he's Azure MVP, Joshua Santasalo, so we were trying to figure out that what are these attributes, because they are not member of the Graph API user object scheme. So there's no information of those attributes anywhere. And we were like, what is this then using to get those? And it turns out that it is using an application called Azure AD Domain Services Sync. So this is an application in Azure AD that is created when you deploy AADDS. So it creates an application, and that synchronization agent is using this application ID to get those changed users and user passwords. But we were thinking that how is it that this application can access attributes that shouldn't exist in the first place? And we tried to create our own apps to get that information, but that failed. After doing some testing, it turned out that only this application can get those properties. So no other application can do that. And we would try to find out, is there a way that we could create our own app to give that ability to access those attributes, but we couldn't find any way. So there's no legit way that which normal end users can do to get in the same situation. So if you want to get access to those attributes, you really need to deploy AADDS so that it will create this application, which you can then use to do that. And also it turned out this application is using a client certificate, a certificate as a client credentials. And that certificate is stored in personal store of AADDS DCs, so it's right there. So it's not in Key Vault, it's there. And also the encryption certificate or decryption is also stored in the same place. So it's not in Key Vault either. It might have been at some point, but now it's not. So when it's used, it's in that plain old certificate store of that local computer. So, results of this research then. So it turns out that AADDS is actually pulling those objects from Azure AD using that certain application. And those legacy credentials are only available for that application. So you need to use that application to get those. And it's using client certificates. However, it turns out that if you are a global admin, and that application is actually in your Azure AD, as a global admin or application admin or whatever permission that requires, you can add new credentials to that application. So you don't need to use that certificate. You can just add your new credentials and you can use that application. And those credentials were encrypted or decrypted using that certain certificate, and you need that one to decrypt those. So with that, this application and the credentials you added, you can get those from Azure AD, but you need to have this certificate so that you can actually decrypt those or dump them. And what else? Yes, so when you compromise those instances, I mean, when you get domain admin, they will be suspended in 20 minutes or anything between 20 minutes and 2 days, so that was our experience, which means that you can't use that domain AADDS anymore, so it's suspended. But it was okay, so you could just delete that and continue. And this just means that Microsoft is monitoring those, and this is what it looks like when they have suspended that. So this is in failed state, please contact Azure AD support. Well, we didn't. We just deleted that and then deployed a new one. And this happened quite close to Christmas last year, so I was having a vacation with my family in Spain, where it's always warm and sunny. And I noticed in the morning that I got email from Microsoft in a weird Gmail address, which I usually don't use. And the title was that elevation of privilege report request on Azure AD domain services. And they said that, okay, we noticed that you did this and did also some post-exploitation, which is a bad thing, and you're supposed to suspend it. And we sent the report, or actually the guys who did the domain admin stuff, so they sent the report, and then we promised that we won't be doing anymore this kind of research. And here was actually one nice thing. So they reported those 2 CVEs they used, and they said that yes, there's an issue with that, but you are not going to get bounty for that. They asked why. Because these are CVEs. Yes. You should have updated those domain controllers. And we were like, they are managed by you, we can't do that. So they actually had all AADDS domain controls, they were vulnerable to those two CVEs. So it took like, when did they fix it? In March, so it took like 3 months to update all those. And yeah. But anyways, this is now the kind of complete graph how to do that. So you deploy AADDS, you get domain admin, and then you have a choice that do you want to dump them from AD or do you want to dump them from AAD? And of course I like the AAD part more because those hashes are stored in Azure AD indefinitely, so they are not taken away even though when you undeploy AADDS. And as long as you have the encryption certificate, you can decrypt those. Even though that the AADDS would be like in failed state, you can still access that stuff in Azure AD. However, AD is better because you don't need to have those encryption certificates. You can just dump them from local AD. So there are pros and cons for both, but yeah. Okay, and now one challenge which is related to Azure AD. So if you want to dump them from there, so it's here, a nice picture, a lot of colorful stuff. So Azure AD, in any given time, Azure AD has only one encryption certificate. So when you create a user or you synchronize user for on-prem, it is using that certificate to encrypt stuff. But in AADDS, you have a current one and then also the previous one. Because there might be a short amount of time that Azure AD might be using the current one and the previous one if you are in the middle of the process of updating those. So for instance, here the user number 1 is created on January 1st. So that credentials, NTHashes is encrypted using certificate from January. And then the other one was created in February, so that is encrypted with a certificate from February. And now when you go from February to March, what happens is that you got new current certificates in Azure AD and then also in AADDS, which means that in any given time in Azure AD, you might have NTHashes encrypted with different certificates. You can have like hundreds of them, different certificates. Why? Because Azure AD is only using the current one. So whenever password is updated, it's encrypted with the current one, and so on. But AADDS doesn't care about that because whenever password is changed, it's using the certificate that is current then and to decrypt that, and then it's in AADDS, DCs. So this one doesn't have, it doesn't even need the access to the older ones because it's already synchronized there. And whenever the new password is added or reset, it is using the current one. So that's a bit of a challenge there. Okay, so I think I'm actually a bit ahead of time, but that's okay. So we have time for demos if you want to see one, maybe. Okay. So the demoing this is a bit of challenging because we don't have any more access to those AADDS, but I have a tenant that I used to do this research, which means that there are users that has NTHashes. I also have the certificates. I saved them during my research because that's what you should do, because you never know when your access is cut. Then we added an application. Sorry, there was the synchronization application, and I added a new password for that, so I can use that. I need to provide the client ID, and with those, I should be able to do the magic. So let's see. Yeah, and I have like 2 certificates here. So one is from December 19th and other one 21st. So let's try the first one. So these are actually in the new version of AAD journals. I hope I'm able to publish it this week. And then I provide a client password. and then the client ID. So I don't need that client certificate. And then I'm going to provide the pfx file name like that. And now it dumped the NTHashes for 3 users. Now if I use the verbose switch, it shows what it's actually doing there. So it shows that, here it starts. So decryption failed for these users, which means that we have the wrong certificate. These people doesn't have NTHash. And everything failed means that it has been encrypted using the different certificate. But here we had like 3 of those. And if I'm using another one, I should have, well, at least 1 user. Yeah. So, yes, so this proves that you can actually do that. So if you just have that certificate and that application deployed. So you can do this kind of stuff. And you can do also like some stupid stuff like you can set your own passwords for users. You can provide the hash value, and I'm using that full of zeros. What else? I'm going to say include legacy. And when I do that, I'm able to add user a new password. And this is synchronized to AADDS if that's deployed. But we can't do anything about that. So we can decrypt that because what we were using is actually a certificate which is currently available in Azure AD. So if I do the verbose, I can see that that's the thumbprint, and the name is controls of Azure Labs.online. However, if I do like this, so I provide the certificate. Now it's there, and you can see that it was a different one. So this is Fabricam Azure Labs Online or whatever. And now if we go here, we should see that. So we can also add our own stuff there and encrypt that using our stuff. Is there any use case for that? I don't know, but it looks nice. Okay. So those were the demos. And then some open questions. So for instance, which I don't know yet, so how those certificates are deployed to AADDS DCs, so that would be nice to know. So are they actually pulling them from some Azure Vault? I don't know, it would be nice to know. But if you are able to compromise those DCs, let me know so we can take a look. And also how these are updated. So what party, when and how is updating those, both the hash encryption certificate, but also that client certificate. And is there other hidden properties that certain synchronization app can access? And actually, it turns out that there is none, because that is using the Graph API version 1, and it doesn't show those hidden attributes, but if you are using beta, then it will show those. So it is showing everything that this app has permissions to do. So apparently none. But this is more interesting. Are there other applications that might have same kind of properties so that they can access some undocumented or hidden properties? So that would be actually quite nice to study. So add your own credentials to every app you can, and then try to use the Graph API beta and see if there's any properties that shouldn't be there. Okay, and then finally the attack path from cloud admin to on-prem admin. So it starts by deploying AADDS. And the funny part is that if you are using password hash synchronization and your cloud admin is just adding or deploying AADDS, Azure AD Connect is automatically starts to synchronize NTHashes. You don't need to do any configuration changes in AAD Connect server, just that cloud admin turns this on. So now they are synchronizing stuff to Azure AD. And then you get the domain admin and dump the hashes. And if you have those hashes, then you can try to use them in target domain, or you can try to crack them. So that way, in theory, you can do that kind of attacks. And now, Secureworks is producing a product called THashes, that's XDR, so we build all the countermeasures already in our product, but those of you who are not using our product, we provided you some custom query language stuff so that you can detect this. So here's deployment stuff. So for instance, if an application principal called Azure AD Domain Services Sync is created by this service principal, it's always domain control services. That's actually a weird one because there's no log entry when that is created. It just appears there, and it always have the same application ID, for instance. So I don't know where it came from. But anyways, that user is creating new service principal, then it's adding that application. So that's another thing to notice. And then here is how you can detect when somebody is adding new client credentials to that application when the user is not the domain controller services, because it is updating those certificates in regular times, but if it's not that, then it is some malicious activity. And the last one is interesting. So we have a KQL queries to things that doesn't exist yet. So Microsoft announced, I think it was in April, that they are going to publish a thing called Microsoft Graph Activity Logs, but it's not there yet. I'm not sure when it's going to be out there. But anyway, you can monitor things like if there's a get method to this URL by this application ID that doesn't contain delta, because that's how it usually gets deltas. But if you are using something else, anything else with that application ID, then that's alarming. And this is actually a nice trick from Joshua Santasalo that how you can get that application ID. So you just search this AD service principal signing logs with that name, and then you can get the application ID, and you can use that later on other queries. Yes, so that was that. So thanks for having me, and if you have any questions, I might have some answers.
Who has a question?
Hi, thanks for the talk, great talk. And question, you said the attack path from cloud admin to on-prem admin or on-prem having the hashes is being on-prem admin, activating AADDS, and then getting domain admin onto these two domain controllers that are deployed automatically for you, and then dumping the hashes. In your research, you said you used the two CVEs to get to domain admin. So this path is not there by default and should not be there, right?
Yeah, that's not possible anymore. Correct.
Okay, so what we need now for this path to work, what we would need now would be either have a path from getting to domain admin in these AADDS world, which is there is not. You're not domain admin, you're not enterprise admin. So either have a primitive from the rights you have, or have a way to get the hashes without being domain admin and without being enterprise admin, right? So I guess you have a group policy, object rights, and stuff like that. So if that would be sufficient to get the hashes, then this attack path would work. Is that correct?
Yeah, for sure, yes.
Thank you.
Yeah. And by the way, you meant group policies, so you can add group policies, but nothing that would affect like those domain controllers. When I was domain admin, I did that so that I create a group policy that says that you need to use my proxy. So it was nice when I deployed new domain controllers, they will start using my proxy. I'm in Finland, so you can do things like that, but you need to be domain admin. And currently, those CVEs are not there anymore. Well, you can use them, but there are plenty of ways I would imagine that you guys can get domain admin.
Thank you. Any further question?
Not him.
Great talk, of course.
Thanks.
So you're saying that Microsoft was deploying vulnerable images that they didn't patch to them, or because it's supposed to be Microsoft managed, right? So I would expect that they apply the monthly patch cycle, or was it just because you deploy them and then they are in an unpatched state for a while, or was it like they don't patch them and they're there indefinitely in whichever vulnerable image template they are deployed from?
Yeah, well, it appears that they deployed like vulnerable images for some reason, I don't know. So there was something wrong in their patching process, obviously.
All right, that's. I would be concerned if I would be using this service, but I'm not. So, but thanks for your answer.
Yeah.
Did you test it if trust relationships are possible from AADDS to on-prem AD?
Yes, you can do that. So you can make Azure, I don't know which way it goes, but you can make it so that Azure AADDS is trusting user information in your on-prem AD. So you can do that if you want to. And of course, there are some attack scenarios, which again are out of bound of my skills, but yeah, there's a way to, there should be a way inside via that path too. It's actually nice because you all look like robots because you have that small screen in your chest.
One more question. How long did it last from the exploiting of the CVEs to this email Microsoft wrote to you that there was some activity detected and so on?
A couple of days.
So less than a week?
Yeah, yes.
But more than 1 or 2 days?
Yeah, because we, yes.
But,
yes.
And just asking, because as a corporate, you have no way of detecting some of this activity on these domain controllers from the AADS because you have no control about it, you cannot monitor it, you cannot audit it, you have nothing to do about it, just to trust that Microsoft is auditing this activity for you.
Yeah, well, actually, you can send login events to Azure Event Hub from those DCs, and then you can monitor them. But we didn't save any data, so we don't have any KQLs for that. But that way you can see if somebody is domain admin that shouldn't be, for instance. If somebody is logging into those DCs with RDP, which by default is enabled.
This you can activate beforehand, so you
yes.
don't need to be admin to activate this monitoring?
Yes, so you need to be a cloud admin. So when you are deploying that, you can connect that to
thanks.
Event Hubs, yeah. But they contacted me after we did that several times. So of course, when they, disabled those, they noticed that, and the fastest one was 20 minutes. So we need to be quite fast to study things. But then they kind of maybe got bored because we are doing that all the time. So it took maybe too long.
Thank you for the talk. My question is, do you look at the Azure AD, how this legacy encrypted password are stored? Are they removed after you're deleting the AADDS version and so on, or they are updated because maybe a scenario is you deleted AADDS, then you reinstall it, and how do you get then the certificates for the very old ones when they are not updated or deleted or changed in a way?
Yeah, many questions, but they are not deleted. So everything here that says decryption failed is added there using some other certificate, and they remain there until you, they remain there.
Forever.
But you don't have, generally you don't have access to those old certificates. I don't know where they are, but you should be able to save them somehow so that you could decrypt everything here.
So you assume that Microsoft is saving them in somehow way, because what helps you with this old encrypted passwords? If the certificates are gone forever, then you can also delete them.
Yeah, but that's, yeah.
Maybe also random stuff from Microsoft.
That's a design choice.
Okay, thank you.
Yeah.
So if there's no further question, thank you very much for your great talk. And we will have some 5 minutes for switching between the story and the next speakers. Thank you very much.
Thank you.